Hello, hello. So today we are going to be talking about z-scores, but I called this z-scores 2.0 because we're going to be doing some challenge problems or just some higher level thinking questions regarding z-scores. These questions are meant to prepare us for AP test questions, IA test questions, and even some of the more rigorous regular test questions. So this goes with section 2.2 in your textbook. Let's begin. Quick reminder about notation. We've talked about this before in the other z-score video, but just some notation updates. The mean can be written as x bar or as mu. We call this mu. So mu is the population notation for mean. X bar is the sample notation. Same thing is true with standard deviation. Sx is the sample standard deviation, where sigma is the population standard deviation. So we have mu and sigma for the population, x bar and sx for the sample. So we are going to be doing this problem or this prompt the entire time, but we're going to go through A, B, C, and D, or 4 different types of challenge problems. So it says ACT scores are reported on a scale from 1 to 36. The distribution in recent years has been roughly normal, with a mean of 20.9 and a standard deviation of 4.8. So those go with the ACT. The SAT scores were reported on a scale from 400 to 1600. SAT scores have been normal with a mean of 1026 and a standard deviation of 209. So we have 2 different distributions. I have my ACT and my SAT. Part A says Jose scores 1287 on the SAT. Assuming that both tests measure the same thing, what score on the ACT is equivalent to Jose's SAT score? So this is the big question I'm trying to answer. What ACT score is equivalent to a 1287 on the SAT? So I answer this with z-scores. So first I want to find his SAT z-score. Well, that would be z equals x of 1287 minus the mean of 1026 divided by the standard deviation of 209. And when I do that, I get 1.25 when I round 2 decimal places. So his z-score on the SAT is a 1.25. So if I want to find his ACT score, what I'm going to do is I'm going to keep this z-score to find the ACT score. I'm going to use 1.25 for the z and say z equals x, which is the ACT score I'm looking for, minus the ACT mean of 20.9 divided by the ACT standard deviation. So what I just did is I took the z-score from the SAT and I'm using that z-score to find his ACT raw score, or the score on the ACT. So when I do some arithmetic, I'm going to scroll down, I times it by 4.8 times 4.8 on both sides. So I get x minus 20.9 because those 4.8s cancel. And 4.8 times 1.25 gives me 6. Add 20.9 to both sides. And I get that 26.9 equals x, which equals the equivalent ACT score. So typically ACT scores are whole numbers, so you could say 27 instead of 26.9, but this would be an appropriate perfect answer. A 26.9 on the ACT is the equivalent score to a 1287 on the SAT. And how I did that was by using the same z-score. So key point number 1, we can use z-scores to compare relative standing in different distributions. So I compare where they are relative to other people in different distributions. Part B says reports on a student's ACT or SAT score usually give the percentile as well as the actual score. Tanya scores 1318 on the SAT. What is her percentile or proportion of observations below? Well, this looks really similar to stuff we've been doing, and it is really similar. It's just sometimes these are challenge problems because they're really wordy. All this is saying is what's the area below a 1318 on the SAT? Well, we know that Table A doesn't have 1318 on it, but it does have z-scores. So I'm going to convert 1318 into a z-score for this SAT data. So z equals 1318, which is my x, minus the mean of 1026, divided by the standard deviation of 209. And when I do that, I get my z is 1.40. So if I draw a new curve down here, this is my regular curve. I have 0 in the middle. I always do 1, 2, 3 tick marks, -1, -2, -3. I mark where 1.40 is, and I'm shading everything below because like it says in the problem, the percentile is the proportion of observations below her score. Well, if I want to find this area, I look at Table A, and on Table A, down at 1.4 in the O column, I get 0.9192. So to give a complete answer now, I can't just give the number. My problem had a lot of context, so my answer needs to have context. I'm going to say Tanya is in about the 92nd percentile. So Tanya's about in the 92nd percentile because 0.9192 rounds up to 92%. So she's about in the 92nd percentile. This would be my complete answer, and I would need to show all of this work to get full credit. Part C says the 25th and 75th are very common to find. So those percentiles are common to find. What ACT scores correspond to the 25th and 75th percentile? So this is a little bit more complex in our thinking because it gives me a percentile now instead of giving me a z-score or a data value. So if I need to work backwards and I'm given the percentile, I'm trying to find what z-score corresponds with this shaded region down here being about 0.2500. Having 0.2500 down here would be the 25th percentile. So I'm trying to find what z-score would give me that value below. Well, if you look at your table, there's two z-scores that are kind of close. You have negative 0.67 and negative 0.68, but negative 0.67 is the closest one. So this is the z-score that corresponds with the 25th percentile. So what I'm going to do, Since it wants the ACT score, meaning it wants the numbers in ACT units, not in z-score units, is I'm going to set negative 0.67 equal to x, which is what I'm looking for, minus the mean of 20.9, I got that from the problem, divided by the standard deviation of 4.8. So I multiply both sides by 4.8. Those cancel, and I'm left with x minus 20.9 on the right side and negative 3.216 on the left side. Add 20.9 to both sides, and I get 17.684 equals x. So if I wanted to write this in context of the problem, I would say an ACT score of 17 or 18 would be about the 25th percentile. So I know this is really sloppy, I'm on my iPad, but an ACT score of 17 or 18 would be about the 25th percentile. Since ACT scores are whole numbers, I didn't want to give 17.684. If you gave this, you would be fine because you did the problem correctly. But just for super formal reasons, we would say 17 or 18. So that's the 25th percentile, but the problem also asks for the 75th percentile. So what I want for you to do is to pause this video and try to find what z-score corresponds with the 75th percentile. Ready? Pause. So when you drew your picture and you wanted 75% to be below the z-score, you got a z-score of positive 0.67. Well, it makes sense that these two are related. Since your normal curve is unimodal and symmetric, negative 0.67 is the 25th percentile, and positive 0.67 is the 75th percentile, because those percentiles mirror each other. So their z-scores should mirror each other. So that's a pretty big concept that we need to understand for the z-scores, is that they're unimodal and symmetric. So the z-score for the 25th is the same, just the opposite sign as the z-score for the 75th. So when I go to find the ACT score that corresponds with the 75th percentile, I get 0.67 equals x minus 20.9 over 4.8. When I multiply both sides by 4.8, they cancel on that side, and I get positive 3.216 equals x minus 20.9. When I add 20.9 to both sides, I get 24.116 equals x. So my final answer for the 75th percentile would be an ACT score of 24 would be about the 75th percentile. So an ACT score, ooh, that's so messy, of 24 would be about the 75th percentile. Since this number is way closer to 24 than it is to 25, I just gave 24. Where here it's kind of in the middle between those two. But for my final answer, I would say an ACT score of 24 would be about the 75th percentile. So this is a very long problem. I know that's why these are challenge problems. But these are very common on IAs, on AP exams, and on problem sets that we do in here for some harder free response questions. So key point number 2 is we can use common percentages to calculate values in context of the problem. So z-scores are building on everything we know about data sets. We're just adding more and more to things that we've been talking about and working with. So everything is building in this class, and it's building towards inference. So last problem is part D. It says what score is needed to be in the top 20th percentile? Well, this is kind of building on what we just talked about with the 25th and 75th percentile. If I want to be in the top 20th percent of ACT scores, that means on my curve, I want to be up here with the area of about 0.2000. Well, if 0.2000 is up here, what does that mean down here is? It's 0.8000. So on my table, I have to look for 0.8000 because my table always gives me the area to the left. And when I look on my table, I get that z is about 0.84. So a z-score of 0.84 would be the 80th percentile, which is also the top 20th percentile. So those things mirror each other. When I do the work to find the actual SAT score, I do 0.84 equals x minus 1026 over 209. We're getting really confident with this. And when I do the cross multiplication, I get that x equals 1201.56, or about a score of a 1202. So a score of a 1202 would be the top 20th percentile for SATs. And I used my table and I used z-scores to help me get to my final answer. So that's a wrap. We can use z-scores and percentiles to work forwards and backwards in a problem. In word problems, we identify the knowns and use formulas in Table A to solve for the unknowns. So this goes with section 2.2 in your textbook, and that's a wrap.